Hi, folks. Welcome to 1.5 Transformations of Functions. And so we're going to start as we typically do with a what we know, right? A quick reminder of some things that maybe we've seen at some point in the past. And maybe as you can tell from this what we know, we've got 3 equations, and we're going to take a look at more what these equations look like what does the picture or the graph look like, okay? So let's start with our f of x equals x. And that, my friends, we may remember is something where we just have a line. And in fact, we have a sort of diagonal line that goes right through the origin, right? And this would be a linear function, okay? And if we take a look at this second one, f of x equals x squared, we might remember that that looks something like this. So our U shape, we call it a parabola. And then last but not least, f of x equals absolute value of x. This might be something that we remember as well. And if we don't, that's okay. We'll put a quick picture with it. Kind of looks like the f of x equals x, except instead of being a line, it's more like a V shape, okay? In fact, the output here should always be a positive value. All right, so we've got a line, we've got a parabola, we've got an absolute value function. Those are things that maybe we've seen at some point in the past. And what's new, all right? So what's new, we're going to take a look at the f of x equals the square root of x graph. We want to add that to the list of graphs that we know pretty well. And same thing with this f of x equals x cubed. We want this to be something that we can visualize pretty quickly, all right? And then we're going to finish off today with something called graph transformations. And this is a complicated looking formula, but once we break down the 4 different pieces, I think we'll find that it's actually a really powerful tool that can work for any of the functions that we just talked about. Okay. So that's where we're headed today, folks. A little what we know, what's new, and we're going to go ahead and get started with the idea of parent functions. Okay. So parent functions. It turns out that in math, there's a lot of what we call families of functions. So quadratics might be a family of function. Linear might be a family of function, right? So linear, quadratic, absolute value. These are all families of functions. But this phrase, a parent function, it just means the simplest form of any function family. Right? So let's put some pictures with all these words. And in fact, we're going to get started with some even parent functions. Okay. And the first one we're going to do right here is we're going to go ahead and start at the origin, 0, 0. And then I'm going to go ahead and graph the points 1, 1, 2, 2, 3, 3, 4, 4. And I'm going to do the same thing on the other side, but literally taking this point and reflecting it over here, and taking this point and reflecting it, and taking this point and reflecting it. Okay, so if we reflect all these points, we will get negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. And when we connect these, we end up with a V shape, okay? And so this V shape, if we think about the equation for it, is going to be f of x equals the absolute value of x. All right, those are those long skinny bars. They mean absolute value. And let's go ahead and put a name for that too. Absolute value. Okay. Now, one thing to consider when we're looking at our absolute value functions, all right, is that if we were to take this right half and we were to fold it over the y-axis, we would end up right over here. In fact, it would match exactly with the other half, okay? Visually, that's what we're looking for when we say that something is an even function, okay? And so this is not part of the graph, but I'm going to draw this line here, okay? Just to help us see that we could fold that left and right half over that line and get the same picture. All right, the other even parent function I want us to think about, we're going to start at 0, 0 and 1, 1, but this time we're going to go 2, 4. Okay. And just like before, we're going to take these points and we're going to reflect them over to the other side. And we'll get -2, 4 and -1, 1. And instead of connecting these with a V shape, we actually are going to connect these with a more smooth U shape. Okay. So now if we look at these side by side, we can see that both pictures actually, when we fold them over this line in the middle, the two sides match. Okay. Now the V-shaped one we said was the absolute value. The U-shaped one, we can actually write as f of x equals x squared. All right, and we call this one a quadratic. Right. You might also, let me leave a little bit of room. You might also hear this called the squaring function. Okay, squaring because you're squaring your x values. All right. But in both of these pictures, all right, you can see that we have that line that we can fold the function over. That line, being able to fold over that line, is exactly what an even function looks like, okay? And so both of these right here, these are both even functions, and that means that they have symmetry. That's our fancy word for if we sort of fold it over, we get that same picture, all right? Symmetry about, now it's really important where we fold it over. Turns out if we fold it over the y-axis and the two pieces meet, then we have an even function. So symmetry about the y-axis. Let's go ahead and color that in the purple too, so we can really remind ourselves that that's where our symmetry is. All right, so that is an example, two different examples of an even function. All right, now let's look at some odd parent functions, okay? And the first one that we're going to draw, we're going to start at 0, 0, and then we're going to go 1, 1, 2, 2, 3, 3, 4, 4. But this time, instead of reflecting over this y-axis, okay, we're actually going to reflect it over the y and then the x, okay? So first we're going to reflect it over this, and then we're going to reflect it over this, right? So this point will go to here after the first reflection, and then ultimately end up down here after the second one, okay? This point goes to here and then comes down here. So 2 reflections. And if we keep following that pattern, we actually see that we end up with a line, okay? So let's go ahead and connect all of these, right? And this, we say the equation is f of x equals x, all right? And it is linear, but sometimes folks call it the identity equation or identity function, because whatever you put in for x is exactly what you get out for y, okay? And so just as a reminder, we have this line that we flip it over first, and then we also flip it over this line. So we do two reflections, okay? All right. The other odd function that I want us to take a look at is going to be at 0, 0 and 1, 1, all right? And also -1, -1. Now, it turns out that these are the points for a cubic function. If we were to put in 2, it would be 8, which is all the way up here. So that's off the grid, all right? But I can sort of imagine that it'll get there and imagine that it'll get here, okay? Now, if we take a look at this picture, we can see that if we flip over the y-axis and then we flip over the x-axis, this point goes to here and then ultimately lands down here, okay? Again, two reflections. This one is our f of x equals x cubed, and we call this the cubing function, okay? Our cubing function. Now, just like above, where we wrote a little note, we said that even means symmetry about the y-axis, right? Let's write ourselves a little note here for the odd parent functions. So these are odd functions, and they have symmetry about, right? So when we do those two reflections, like the y and then the x, we say that that is symmetry about the origin. Okay, that's just the same thing as saying symmetry about the origin. Origin would be both the x-axis and the y-axis, right? X and y together. All right, so we've talked about some even parent functions, some odd parent functions, and now let's finish with a parent function that is not even and it's not odd, okay? So let's get a picture going here. We've got 0, 0, 1, 1, 4, 2, right? And we connect it with sort of a smooth curve like that. Turns out this equation is f of x equals the square root of x, and we call this the square root function, okay? Now, this is the whole function. So if I think about that y-axis here, all right, I notice that if I flip this over the y-axis, it's not going to match with anything because there's no picture on this side, okay? So it's not even. And then in order to check whether it's odd from a graph, we would sort of sketch in this other line. That would mean this point would end up like down here. Or 4, 2 would move here and then ultimately down here. But we run into the same issue. There's no picture down here. So using our reflections, we can see that this is not even. There's no y-axis symmetry. And it is not odd because there's no symmetry about the origin, okay? So origin means both, but then it's not even either because there's not even symmetry about the y-axis, okay? And so that's where we're going to stop for part 1 here. All right, I want to give us an overview of some functions that we're going to see quite a bit of over the semester, and that you'll also see a lot in calculus when you get there. Okay, so come back here for part 2 of 1.5.